Hey everyone, this is section 12.1 chi-square test for the difference between two proportions, and this is question number 3. So we are given the contingency table over here, and those are basically the observed values, and what we want to do, we want to figure out what are the expected frequencies, right? Okay, I downloaded already the table. Let's be clear up first. So those are observed frequencies, and these are the values that we have, right? All right, so only 2 by 2. All right, the rest of the values are the totals, which is the sum of the columns, the sum of the rows. All right, okay, so what I'm going to do here, I'm going to just figure out what is the percentage of each row overall. So the overall is 100, and this is going to be equal sign. So the total of the row, which is 70 in this case, and divided by 100 here. So that's going to be 0.7, which is 70%. And the same thing I'm going to do for the second row. So it's going to be equal sign, click on the 30, divide by the 100, enter. Okay, so I need these two values. Then what you're going to do, you're going to copy this table, you're going to paste it here, and what you want to use paste as values. You don't want to paste it like a regular paste. So I need the values here, and you could as well paste it as format if you want to do this, right? So this is going to give you the borders and everything else. Okay, the most important of the values here, they are values, right? They are not connected to the previous table. Okay, I'm gonna change the name of the table from observed to expected. I'm gonna clear the values here. I leave everything else, right? I might as well clear or change the color. So this is gonna be light blue. All right, so I am looking for these 4 values over here, which is 2 by 2. So I'm gonna click equal sign, and I'm gonna select the total of that column, which is 70 here in this case, multiplied by the percentage that I calculated earlier, and that's gonna give me 49. So I do it again for each one of them, right? So again, equal sign. So if I'm going to do this, for example, it's going to be the subtotal of that column, which is 30, multiplied by the percentage for that particular cell on the rows, right? So always the cross, all right? So again, let me draw it. So if I'm going to do this number, it's going to be this subtotal over here and this percentage over here, right? So it's always crossing, all right? Okay, so you're going to be equal sign here, select the subtotal times 0.3, one, you're going to be equal sign subtotal times 0.7. Okay, so those are the 4 values that I'm looking for. Just type them in. All right, let's check it. Great. Now, for this statement, they are telling you when you add the numbers, the expected values versus the observed frequencies. So the previous table, we know the sums are going to be 70 here. If I add them up, so if I add this, it's going to be 70. You're going to add them up here, this is going to be 70. And if you're going to do the overall, it's going to be 100, right? So the sum of each column and the sum of each row. It happens you can verify it as well for the expected value. 49 plus 21, it's going to be 70. For this column here, 49 and 21, 70 again. That the number didn't change. Here, 21 and 9, it's going to be 30. And you can see it here, right? They are all matching. All right, so this does not change the subtotal and the overall total. So the expected values are always the same as the observed, expected, and they are the same. So this one is gonna be the best choice is C. Okay, so for the null hypothesis, this sentence from your book, so 80 is gonna be ours. The proportions are the same, or there is no difference between the proportions. So this is our null hypothesis, and the H1 is going to be ours. The two proportions are different from each other, or there is a difference between the two proportions, right? So again, this is straight from the book, and the best choice is going to be B here. All right, so now we are looking for chi-squared stat, and the formula is right here. So what you want to do is you want to calculate, first of all, you're going to take the observed value, you're going to take away from it the expected value, then you're going to square it, and after that you're going to divide by the expected value, right, or frequencies, right? So you want to do this for every single cell. Means we're gonna see it in a moment, right? After you do all the values here, you're gonna go back and do the sum of them. All right, so if I have this table, right, so this is my two tables here. So again, let me bring the formula, and I'm gonna need the same 2 by 2 table. All right, so do you see here the yellow table is 2 by 2, the blue one 2 by 2, so I'm going to need another table 2 by 2. Okay, let's put it orange. So what you want to have to do, so for example, the upper right cell, so which is this one, 57, that's going to be the observed frequency, and the upper right cell again for the expected value, which is 49, is going to be the expected frequency. And here you're going to do the calculation, which is this formula. All right, F0 minus Fe squared divided by Fe. Okay, let's start with the first cell. So I'm going to click on equal sign. I'm going to open the parentheses, select the 57, which is the observed frequency, take away minus sign the expected frequency, which is 49, close the parentheses, shift 6, which is exponents 2, so exponents 2 here squared, and then divide, which is the backslash, and divide by the 49 again, which is the expected frequency. And that would be the first value. Usually what you're going to do here, you're going to select this and drag it around, but I'm going to do it again one more time so you can see the process. So for example, if I'm going to go to this cell, so that's the bottom right one, so I'm going to use all the bottoms right cells. All right, so you're going to be equal sign, open a parentheses. I start with the observed values here, 17 minus the expected corresponding expected value, which is 9, close the parentheses, shift 6 and 2, that's squared, divide by the expected value again, which is 9, so you have to click on it again one more time. Okay, so those are two values. Now if I have a contingency table, it's easier actually to select one cell here, drag it down, for example here, and that's going to give you another value. And if you drag it down, well, you drag it on the right side right now, depend what is your table, you're going to get the remaining values. And you can double check, for example, this double check here, and you see the selected cells are the upper right. All right. Okay, so we get all these FEs right now. So this is, we get all of them. All right, for this case, there are 4 of them. So now what I want to do, I want to do the sum. So I'm jumping to this table. All right, so I'm gonna select the chi-squared test statistic, which is chi-stat I'm looking for. You're going to be equal sign and do sum, open a parentheses, and select all the values here, right? And enter. So you're going to be 14.51. By the way, I'm using this table as a reference from your book. So this is probably the last page of the section, and you have all the formulas in case you want to go back and see in details, right? Okay, so let's go back. We get our chi-squared test is 14.51, paste it there, and round to 2 decimal places. Good. All right, the p-value now. So in order to get the p-value, you need your degree of freedom, level of significance. Well, you don't need a level of significance, but you need definitely a degree of freedom. So let's work a little bit on the degree of freedom. All right, so level of significance for this question is 0.05. The number of rows, so we have 2 by 2 contingency table, so you can be 2. The number of columns, you can be 2 as well. And here, degree of freedom. And as a matter of fact, the degree of freedom is going to be always the number of rows minus 1 times the number of columns minus 1. So in this case, it's really easy. 2 minus 1 is 1. 2 minus 1 is 1. 1 times 1 is going to be 1. So we know it's 1. I can generate a formula. So if I have a different contingency table, probably I can put it right away here, right? So the formula doesn't change. You can change the number of rows and number of columns and level of significance, but you can keep the formula for the future questions. All right, so you're going to be open a parentheses, and I'm going to select number of rows, which is this one, minus 1. And then I multiply it by open a parentheses, number of columns, minus 1, and close and enter. So that's the formula applied there. All right, so I highlighted this sentence from your textbook, so for reference, right? Okay, now the p-value again. Again, if I go to this table, you can see here the p-value, and is that the formula chi-squared distribution RT, all right? So that's what I'm going to apply. Your freedom. You're going to be equal sign and then chi. As soon as you put chi, you can see chi-squared distribution RT. So RT basically right tail and chi-squared is chi distribution basically, right? All right, so I'm going to select this one. And then it's asking me about the X, as you can see here. The first bolded letter is X. X is the statistical value. So I'm going to select this value here, put a comma, and then it's asking about degree of freedom. And degree of freedom, we say 1 here. So we select this one and enter. So that's going to be my p-value, which is 0.000, right? Right, let's go back. All right, so to make a decision is pretty much the same thing as we did before. So if you are already in 12.1, you know how you make a decision already for the null hypothesis. This is my chi-squared distribution. This is my critical value. So the place where the critical value ends here, this is going to be alpha. So let's assume alpha is going to be 0.05. 0.005. All right, now I'm going to make a decision accordingly with the p-value, so the alpha value versus the p-value. And if I'm going to graph my p-value right now, and you can see the p-value is 0. All right, so it is very tiny. So this small line here basically is your p-value, right? So this is my p-value. So if the p-value there, this is going to be my technically my chi-squared that. And that's what is 14.51. Okay. Now the critical value, we don't really know it. All right, so we didn't calculate it and we don't know exactly what is it, but we know is actually smaller definitely than 14.51. Anyways, so the chi-squared stat, whatever's top here at the p-value, is within the rejection zone of 80. So definitely I'm rejecting 80. All right, so we are not going to do this process again, so I'm just putting the formula one more time. So very similar to this statement here, reject 80 if chi-squared stat is greater than chi-squared alpha. We're gonna add another formula, which is reject, all right, 80 if the p-value is less than the alpha value. So this is the sentence that you're gonna be using as a reference, all right? And obviously here 0 is smaller than 0.005, so definitely I'm rejecting 80. So your conclusion here, reject 80. So if you reject 80, all right, so the p-value is smaller than the alpha, reject 80, and every time you reject, you have sufficient evidence, right, or enough evidence. Okay, so yes, we do have evidence, right? So that's the three statement goes together. Now, obviously going to be either A, all right, level of significance, yes, because the p-value here, or yes, because of the p-value here. So here is saying the p-value less or equal than alpha, the p-value less than or equal than alpha, both of them the same statement. So p-value small, yes, reject. All right, therefore the null hypothesis should be rejected, and here the null hypothesis should not be rejected. So definitely we said reject, so we're gonna go with C. Okay.